Swayam Prabha. Digital India. Educated India.
Okay, good morning. So we'll be starting some new kind of topic from now on. This is to do with life cycle analysis. Okay, so if you recollect from the introductory lectures, we were talking about sustainability, and in particular, we were talking about sustainable plastics. That's a course. So we looked at various aspects of sustainability, what it means, and we said there are three capitals that we have to watch out for whenever we try to manufacture something or produce something, right? So these are natural capital, which involves natural resources and how we impact them. Then there is this social capital or human capital, that is to do with how we manage people, society, cultural values, etc. Then the third thing is about financial capital, which we all of us understand that anything that we produce should be economically viable. That means you should be able to add value, you should be able to make profit. Okay, so those are the three constraints we have to operate. So before we talked about sustainability, it was all about maximizing the financial capital. How can I make larger profit? Not worrying too much about the social capital or the natural capital. So now when we talk about sustainability, we say no, financial capital is not the only one determining factor. We have to take into account of other capital too. So we have said all those things from a qualitative terms, right? So now when we try to assess what are the impact on the natural capital, we need some sort of a framework with which we can assess when I make a product or when I offer a service, what are the things that are involved, what are the impact that we are going to create on the environment. Okay, so that is the context of this life cycle analysis. Sometimes it's called life cycle assessment also. Okay, so in short we say LCA. Okay, so LCA has become one of the important requirement in these days whenever we propose a process or a product. Okay, so they ask what is the LCA analysis of this service or product or manufacturing practice. Okay, so in this lecture I will give a broad overview of how this framework works, and later on we will see some examples and case studies. Okay, so what is the scope? If you ask what is the scope of this LCA, it's basically trying to compare the environmental impact of producing products. So here I put plastic products because this course is about plastics. Okay, you can actually replace plastic to something else. For example, let's say you want to manufacture a EV scooter. You could ask what are the relative impacts of having an electrical scooter versus IC engine based scooter. Okay, so this product can be anything. It need not be a product, it can be a service also. Okay, for example, you can assess between food delivery apps with which we order food and get delivered, that's a kind of service, versus cooking at home. What is the environmental impact of these two activities? Okay, so LCA basically gives a framework with which we can assess relative merits and demerits of activities. Okay, it can be manufacturing, it can be process or product development, etc. When we say environmental impact, what we actually mean is how much greenhouse gases are emitted, how much CO2 is produced, how much methane is produced. Okay, because these are relevant from a climate change point of view. We know that increasing the concentration of greenhouse gases in the ambient is going to increase the surface temperature of Earth. So that's going to lead to change of weather pattern and excessive heating and various other ecological impacts. Okay, so one aspect of this impact analysis is to find out how much greenhouse gases are emitted because of this process. Okay, so we want to give a number to it, we want to quantify it. Then we also want to know how much solid and liquid waste we are going to create. Okay, so whenever we manufacture something, we consume raw material and we produce a product, but the product will not be always a pure product. There is going to be some impurities, some waste that has to be separated. So we only add value to the product finished goods that are ready to use, functional. There is going to be some sort of a byproduct generated, which we could call them as waste or some low value product. So what are the amounts, kilograms, tons of waste that are created? Okay, one good example is packaging waste. Okay, you make a product, you pack it, ship it. Okay, and the consumer is going to use only the product that you made, not the packaging that you provide. So the package material, which kind of preserves the life of this, which preserves the freshness and the newness of the product. Once it is opened, unpacked, you are not going to use, the user is not going to use the packaging material, he is going to throw it away. So you can say how much solid waste is created because of packaging, right? So we want to quantify that. Also, how much air and water pollution we are creating. Okay, for example, if you think about let's say a dye industry. Okay, so let's say you have a garment factory and you are making some textile and you use some dyes and coloring agents, pigments. Okay, so here in this process you are going to use some water. Okay, after the process, this water or contaminated water or the wastewater has to be managed. So you want to know how many liters, how many gallons of wastewater will be created, right? Let's say you want to make power out of coal, and then you're going to burn coal and it's going to give you a lot of particulate matter. CO2 we have accompanied, but apart from CO2 there is going to be also some air polluting contaminants. So you want to assess what is the volume of pollutants that are created that will pollute air. So when we say environmental impact, this is what we mean. We want to know how much greenhouse gases, how much solid and liquid waste generated, and how much are we polluting air and water. So these are the context with which we want to assess, and we want to give a quantitative number for this. Okay. Now when we try to do this, we actually think about 2 to 3 different kinds of analysis. So there is something called, which you might have actually heard of this, a cradle to gate. Okay, so what this means is, when you think about a product or service or a manufacturing, you take raw material and make a product. You look at only what comes in and what goes out in this particular raw material to product only. Okay, so gate means it's just product is leaving the gate and you're stopping the analysis right there. You're going to look at everything that happens between that, taking a raw material, manufacturing it, and then getting the finished product. So that we call as a cradle to gate. There is another approach called cradle to grave. In this case, we are not only confining up to manufacturing and packing, but also you are going to look at how this product is going to be used, okay, from the user's point of view. And after the user is used, what is going to happen to the product? What is the end of life of that product? Okay, very typical example, as we say, PET bottles, let's say. Okay, so you kind of consume crude oil and then petroleum. From there you make terephthalic acid and ethylene glycol. Those are the raw material for PET. Okay, and then you're going to make a PET bottle, and then you're going to fill water into it, and then you pack the water and send it. Okay, so if you confine your analysis only to this, we say it is cradle to gate. You manufacture a water bottle and you supplied it, that's it. You're not so the assessment stops there. This is one approach, but the problem with this approach is we are not liable, we are not considerate to see what is going to be the fate of this water bottle after use or during use. So then we slowly go to another level where we say we don't stop at the gate, we go all the way up to the grave. Grave meaning grave of the product. So in this case of example of a PET bottle, you ask, I take raw material, petroleum, natural gas, whatever it is, I process, make polymers, and I have PET molecules, polymers. I then kind of inject mold them, blow mold them, make it a bottle, fill water, package it. Then I'm also going to take where this water is going to be used, who is the consumer. After that water bottle is opened and consumed, what is the end of life of that bottle? You could say maybe I have a mechanism with which I can recycle it, or there is a mechanism with which I can landfill it, or maybe there is a mechanism with which I can burn and get some energy out of it. So these are end of life options: recycle it, waste to energy, or landfill. Each of them will have a different impacts. So when you try to do LCA analysis, you have to make these assumptions, these considerations. Okay. The last one is called this cradle to cradle. This is a best case scenario, in which case you start with the raw material, make the product, look at the, what goes in during the use of the material, and then the end of life has to be a recycling option where the material comes back to the original raw material. So you basically close the loop. This is what we call as a circular economy, right? Where the raw material is used to make the product, and the product after use is recycled so that it can go back to the raw material with which we can make new kind of new bottles. Okay, so that is cradle to cradle. So when we try to look at LC analysis, we ask whether the LC analysis is to be done for cradle to gate or cradle to grave or cradle to cradle. Okay, so that's the way that we do our LC analysis will change depending upon which end of life options or which type of model we want to study. Okay, I will give you a little bit more example on these things later on. Now, the LC analysis, even though it has a very long history, as of now, I think it's pretty standardized. Okay, so there are ISO standards 14040 2009. There is also another one ISO 14044, right? So these are the two standards with which we perform LC analysis. And why we need standard is because if you do a LC analysis here and someone else doing a similar LC analysis elsewhere for the same product should be compared. So standardization becomes very important. Okay, so ISO standard 14040 or 14044 are the two standards with which LCA happens. As per this standard, LCA analysis has to be done in 4 steps. Okay, the first step is to define what are the goals and scope of the LCA analysis. Okay, so we have to say what. So I will come to each of this separately later on. Defining goal and scope is one. Then there is a inventory. Okay, this inventory list is a key input for the LC analysis. It's going to tell you how much energy, how much material, what are the transportation inputs, what are the waste generated as an output. All these information, which we call them as inventory database, will have to be provided. The third thing is to assess what are the impact of the emission based on these inventory information. Okay, so as I said, you basically want to ask how much CO2 is created, how much waste, liquid waste, solid waste is created, how much air pollution, water pollution is created in a quantitative basis. And finally, we try to interpret. Okay, so these are the 4 steps that has to happen in the as per the standard ISO 14040. So it's pictorially shown here. So you start with the goal. You say you have to define what is the objective, what is the scope of this LCA, why do you want to do this. Okay, the second thing is to give this input data, which we call as inventory analysis, essentially material balance, energy balance, and stuff like that, and then assessing impact and then interpreting it. So this interpretation could actually mean you can go back and then change few of the assumptions, you can change few of the, so it's a very iterative process in that sense. Okay, so this is the 4-step method with which LC analysis is done as per the ISO standards. So now let's go back to the stepwise. Okay, so the first step is to define the goal and scope. So in this particular step, we basically say what is the purpose of doing it, why do we want to do it. Okay, so here, as I said before, we want to assess the environmental impact of a product or a process or a service with regard to either cradle to gate or cradle to grave or cradle to cradle. So this is something that we have to specify under these purpose, what are the environmental impacts, right? And then we also make a lot of assumptions. Assumptions basically means that there will be a variety of ways in which we can do a process. Okay, so we have to look at what is the best thing for us to do. For example, you could say, if you consider transportation, you have a choice to make. You could say, I'm going to transport my raw material with a truck by road or by rail or by shipping or by air freight. So these are the assumptions you have to make. Okay, and sometimes there may not be adequate road transport, so you may have to do only shipping or air freight. Okay, so sometimes these assumptions, sometimes all options may be all possibilities may be available for you. So it is important for us to assume which is the mode of transportation. Again, end of life, like I said, am I going to recycle it, am I going to landfill it? So again, that is also coming under assumption, okay, or whether I am going to do waste to energy or composting or landfilling. So we have to make assumption about these end of life also. And one of the key thing in this is to define a functional unit, okay. So functional unit basically, if I have to compare with the thermodynamics, in thermodynamics we say system, and then we say boundary, and then we say surrounding. So system is a unit within which you want to focus your attention of various processes that happen, okay, and the system will have a boundary with which it can interact with the surrounding. In the same way, in the LCA analysis, the functional unit resembles this system that we consider in thermodynamics. It is the object of our observation context within which we want to see what happens, okay. So it could actually we do that because we can actually compare with different material, processes and services. For example, if I say bottles, water bottles, so that is my functional unit, okay, because it's going to serve a function of storing some water I can carry along, right. So here I can say whether I should be able to make a bottle with PET or with the steel or with the clay or with the plastic. So these are all options. So now once we have a functional unit, then I can compare LC analysis between different materials or also different processes, okay. For example, if it's a clay based material, I am going to use a different process, okay. If I am going to do metal, it's going to have a different processes. So apart for the same material also, you can think about different processes also, okay. So that's the context. So in terms of setting the goal and scope, it means defining the purpose, defining the assumptions, defining the function units. So these three things we have to do in the first step, okay. This is a very basic, more like initialization kind of a step. The second step is a very important step. This is where we get a lot of uncertainty also, okay, because of the various data that is required. So this inventory, it's called LCI, life cycle inventory, right. In other words, we call them as a database. So database is basically a catalog. It is basically a large amount of information that gives you materials, energy and transportation needed to produce the raw material and also manufacturing of the products, okay. It's a very large database, okay, and it gives all this material, energy, transportation related information, okay. It also can give you information about how much waste is generated, how much emission is generated in some standard conditions, okay. So here I have given some examples. So what you see on here, these are list of databases. When you read any literature, any research paper on LC analysis, apart from specifying the scope and goal, they will also tell you for this particular analysis we used this particular database. What they actually mean is they have used the data present in this database for material, energy, cost, emission related matters, okay. It's more like a set of information available for doing this LC analysis, right. So for example, if you consider this agri footprint, okay, so that's the name of a database. Some databases are available freely, some are commercial, you have to pay and use, right. If you consider this agri footprint, it actually contains LCA for certain products such as food, agriculture, intermediate products. So whenever you want to do an LCA analysis of agri and food, you would actually use this particular database, okay. There is another one called agri-biolase. This also considers food and agriculture sector, but specific to France. Many of these database are mostly US based, okay, but sometimes we want to do LCA for a local region. For example, if you want to do that for France, one would actually use this agri-biolase, okay, because the cost component, material cost availability could be quite different from one region to another region, okay. So these database could be also specific to certain regions also. I have given only some examples, but actually the list is long. So there is something called this ARVI. This kinds of this looks at inventory for various wood and polymer composite. So if you want to, in this particular course, let's say you want to do LC analysis of a product which could be a composite between polymer and wood products, one would use this ARVI as a database to do the LC analysis. And for biofuels, which based on wood and wheat and other bio waste, there is something called bioenergy date, right. So one would use this one. And this carbon mine has a very large, more than 10,000 unique chemicals and plastic products, and the corresponding inventories are there. And this eco inventory seems to be by large the commonly used database. It's very large, and you can see the kind of sector it can cover. It covers agriculture, animal husbandry, building, construction, chemicals and plastics, energy sector, forestry and wood, metals, textiles, transport, even touristic accommodations. So if you want to build a a cottage, let's say in Kodaikanal or Ooty, and if you want to do an LCA analysis of that, you would actually use this kind of databases. Okay, of course this is not regional specific, but you can imagine something similar would be required. Also waste treatment, recycling, water supply, etc. Okay, so you can see that some databases are very specific to your domain. There are other which are very general, which means that you can actually use that pretty much for all the other purposes also. There is something called this World Steel, which basically talks about only steel products. Okay, so as I said, this list is very long. I have given only some example just to kind of sensitize that what kind of information is needed. Okay, so what we are saying, we are talking about LCA analysis as per ISO 14040 standard, which requires 4 steps to be followed. The first step is to define the scope, the goal and scope of the problem, in which case you say, okay, what is the purpose, what are the assumptions, and what is the functional unit. The second step is to look at all the inventories, okay, material, energy, transportation, and this is usually in terms of some database we use them. Okay, and these are some examples. So here I have given some more sector specific data. So you will see the database availability for various products, for example, for air transportation, chemical manufacturing, crop production, electrical component and computer manufacturing. So you can see this list pretty much covers all the activities that we that we do in terms of manufacturing, services of our society, right. So so you can actually look at what is the LCA analysis that you want to do, and you can choose a database corresponding to that, and from there you go on, right. All right. The third one is this impact assessment. As I said, impact assessment is usually done in a normalized scale. You generally say, okay, if you want to have 1000 grocery bags, if you want to produce 1000 grocery bags, what are the impacts? Okay, or you could say, I want to make 10,000 cell phones. Per 10,000 cell phone produced, what are the impacts? Now, what are the environmental impacts? Or you could say, I am making 1 lakh electronic EV vehicles, okay, electrical vehicles. What is going to be the impact? When I say impact, I actually mean how much energy would be required, what is the CHG, greenhouse emission or carbon dioxide emission or footprint, and how much solid waste, what is the pollution, etc. per a functional unit. Okay, so functional unit, we always say, we try to say some sort of normalization. Okay, you could also say per unit. Per unit may be very small to say, so that's why we say, okay, per 1000 or per 10,000 or per lakh quantities of the functional unit, what are the impact? Okay, so you will see that when I show data, you will see that we usually report so much kilogram of CO2 is emitted per 1000 kilogram of some product created. Okay, so we always do a normalization. In chemical engineering, when we do chemical process calculations, we say something called basis unit, right. We say for 1 kilogram of my product, what are the material requirements, what are the energy requirements. So LCA has a very similar analogy here. Here we also say per so many function units, what are the impacts. So that is step 3. The step 4 is the final one, which is very important one, because after you assess, we have to make sense of these numbers, okay, in a relative sense. First of all, we have to make sure that whatever analysis we have done, whether the data is consistent and accurate. Okay, so this can be done based on studies, something done previously. You compare with literature and compare and contrast between your results and what is reported, so you can find out whether your calculation could be consistent or not. And the accuracy of database also is very important, because this database also keep evolving. Okay, new information is added, so you have to be very careful that which database, which version of the database you are using. Okay, if you are doing molecular simulations, you may be using what's called this force field, and this force field comes with the different versions and it keeps on updated. Okay, so it's really important to know I'm using this force field of this particular version for this particular calculation. Okay, so similarly here the database has to be consistent and accurate. We also do what is called this uncertainty analysis. Later on I will tell you about the sensitivity analysis a little bit more elaborately. And finally, I think the critical aspect is conclusions and recommendations for minimal impact of products, process and services. So that means let's say if you want to take this example of producing 1000 water bottles. Okay, now you may have a choice. Like I said, you can use plastic, you can use wood, you can use steel, or you can use clay or ceramic. Okay, among these choices, you could say if I make 1000 bottles from these material, what are the relative impacts? Okay, you may see that steel may actually have very high energy cost. Okay, but with a very small amount of let's say waste created, versus a plastic bottle which may require less amount of energy, but it may actually have more waste generated. So we have to look at the relative merits of what we can tolerate, whether we can tolerate high energy cost or high energy requirement, or we have to go with the high waste created. Okay, so we have to look at the relative merits of each one of them. So that's what this interpretation and analysis become very important, with which you can make a recommendation. You can say, okay, let us make the bottle with this particular material but this particular process, because you justify your conclusion saying that it would have high energy cost but maybe less polluting or maybe less waste generated. Okay, so you can make a conclusions. So when we look at some case study, we will actually discuss this in more detail, right? So as I said, this LCA standard is as per this ISO. These calculations are not done by hand. It is usually done by a software. Okay, because these calculations are quite intricate and many things are involved, and there are several softwares available. Gabby, Cyma Pro is probably the most famous one, and there is something called Sustainable Minds. Open LCA is also quite common. So Open LCA is a open software. It's free, but the Cyma Pro and Gabby, these are all commercial. Okay, so that means you have to buy the license and to use it. For example, like Aspen, for example, you have a commercial license to do some calculations. Similarly, these software can be bought based on the commercial aspects. So as I said, I was mentioning about cradle to gate and cradle to grave. So if you consider a cradle to gate, this is how you look like, right? So you have a manufactured product or a system that you want to produce. You can see what are the things that goes in. There is some energy that goes in, raw materials goes in, there will be always use of some water, and then there is going to be a transporting requirement because the raw materials are created somewhere, the manufacturing plant is somewhere else. So the transportation, the freight becomes very, very important component, and there could be other specific inputs that may be needed, right? So energy, material, transportation, water, okay, and other utilities. Okay, those are the inputs that goes into the manufacturing process. What do you get out of that? Of course, you get your product. Apart from product, there are various other things you create. You create air pollution because maybe you're burning something. Okay, so you're creating some sort of a pollution. You could probably create some water pollution also. Okay, because you're using a solvent or solvent mixture, or you may be using water to clean greasy products or dye products. So there's going to be some sort of a water pollution. As I said, there's going to be some waste generated in this process because of side unwanted product formation, and then gas emissions, and then there could be other specific things. So this is how we look at the cradle to gate. So here we look at all the material, all the resources required to make a product, and then as soon as a product is created, what are the impacts, what are the outcomes, what are the outputs. So if we stop here, the entire analysis is only done here. If you go to cradle to grave, you see that of course the first part is same as before. We have this entire system of cradle to gate, but further we also integrate the product while in use. What are the things that are required? Sometimes to use a product, you may have to use energy, transportation and others. For example, let's say you make an iron box. So when you use iron box, you are going to use electrical energy while it is in use. So that's what I mean by while product is in use, how much energy is required. And then transportation. Sometimes some product needs to be carried from one place to the other place for its use. Okay, so how much transportation is going to be useful, and various other things depending upon what product that we are talking about. You will see the other thing will always be added everywhere, because there are always some unknowns that could be specific to a product. Okay, that we have to identify and include. Okay. So when you look at the product while in use, it also will create pollution, waste generation and others, right? So that also has to be taken into account. And finally, you also have to look at the end of life. Once the product is in use and finished, discarded, again, what are the energy transportation required, and then what are the pollution waste generated. So you can see that in each of the three stages, manufacturing stage, product in use stage and the end of life stage, in all these cases we need to know what is the end of life. So in end of life, let's say you want to do a incineration. Okay, so you're going to need some energy to incinerate, and you're going to need some product transportation, because you're going to collect the waste from one place and then take it to an incineration plant. So there's going to be some sort of transportation also. So then once you incinerate it, how much pollution you're going to create, how much waste is going to be created post incineration and others. Okay, so you can see that it's very detailed. For a given process, you have to enumerate everything that can go in and go out. Okay, so it's very important to assess all these components. Okay, so now we are coming to this so-called sensitivity analysis. Unlike our chemical process calculations example, where we have a very unique answer. Okay, we know a process, we know what goes in, we do a material balance, energy balance, everything is absolutely fine. You get a unique answer. But LCA analysis is not like that. Okay, because of the complexity involved in in this analysis, multiple energy inputs, database, there are a lot of inaccuracies within the database, will lead to a final conclusion that could be very subjective. So it's very important to actually assess what are the main sources of uncertainty. This uncertainty can come from the quality of database. Okay, the information that is present in the database can be questionable. Maybe it is very region specific. You are using a database that is created in France and you are using it for India. Your results could be quite different. Okay, so how do we eliminate those biases is important. And then impact assessment methods. What are the assumptions? Okay, so each one of them can create some sort of a variation in your final results. So the sensitivity analysis is actually done in one of the three ways. Okay, one is something called this gravity analysis. In this case, you can actually look at the data that gives the highest contribution. Okay, so what that means is, if you have transportation, and you have a choice between going by road versus going by rail. Okay, and each of them can give a different result. Okay, so sometimes you have to say which one gives the maximum impact. Okay, so you can always look at the data that gives a maximum impact and base your conclusions with respect to that. Sometimes we can actually do an uncertainty analysis based on a range of possible results based on data analysis. Instead of saying CO2 produced is 1 kilogram for every 1000 PET bottle created, you can give a range by accommodating all the uncertainties. Okay, so you can give a range of possible answers. Sometimes we actually look at influence of one parameter on the value of the other parameter. Okay, so what that means is, sometimes let's say you have a choice of what is the source of energy that you want to use. Okay, and that can actually give different end of life options. Okay, so one parameter can influence or cause change in other parameter. So you can look at this dependence or correlation between one parameter to other parameter. Okay, so any LCA analysis as per ISO standards will have all the 4 steps. Okay, after that you also have to do the sensitivity analysis, and you have to ensure the conclusion and the recommendation that you make based on the interpretation of the result have to be substantiated with the sensitivity analysis also. Okay. And this ISO standard also gives you a framework, and it tells you what are the quantitative information you need to provide at the end of the LCA cycle. Okay. So, LCA cycle you can do, and then you can do several calculations, and based on that you can make a recommendation. That recommendation should actually have some minimum set of information. Okay. Those are this information. First of all, we have to define what is a functional unit. Am I talking about plastic bags? Am I talking about bottles? Am I talking about vehicles? Or am I talking about textile materials? So that functional unit has to be specified. Okay, without that there is no way of doing it. Then you say per functional unit, or per thousands of functional units, or 10,000 functional units, you say how much energy is going to be required. That you have to give a number to it, right? And the carbon footprint. So carbon footprint basically means how much material that we are going to consume from the nature, and how much waste is going to be generated. This waste includes both solid as well as liquid. And then how much eutrophication is generated, and how much acidification is generated, and transportation, end of life scenarios, and whether it is as per ISO standard or not. Okay. And finally, as I said, the uncertainty analysis also. Okay, so that's all I have. And any questions or discussion at this point?